In this video, I'd like to talk about reference frames. Studying reference frames and understanding what reference frames are, it's important mainly in engineering because you want to know how you are observing motion. A reference frame, it's actually defined as a collection of points such that the distance between these points is constant with respect to time. So what that means is that a reference frame is just a collection of dots, and the relationship between these dots is constant. So they don't move with respect to each other. This might be a little bit different from what you see normally in books or on the internet, where a reference frame is simply drawn using arrows or vectors. You might normally see people referring a reference frame and using this drawing instead of telling you about something that is just essentially fixed. We're going to discuss the difference in a second. So let me first talk about a reference frame. All right, so a reference frame, again, is a collection of points that are fixed or are moving at the constant speed at the most. The minimum number of points required to define a reference frame in three-dimensional space, for example, well, would be 3 points. And these 3 points are to be non-collinear points. If we draw a, let's say, a three-dimensional box, okay, let's draw this three-dimensional box real quick. And if we drop 3 points, right, we require 3 points in three-dimensional space. So let me drop, let me show a better color. We drop 3 points, one here, another one over here, and let's just drop another dot over here. All right, so if we have this, actually let me choose this other dot over here. All right, there we go. If we have these 3 dots and then they're fixed with respect to each other and they are fixed in space, all right, or they're moving at the constant speed, now we're talking about that this is a reference frame. All right, and the reference frame is useful because it helps us to observe motion. All right, so this is interesting. The key word here is observe. The reference frame allows us to make observation regarding motion, but importantly, it does not, all right, take note, this does not provide a way to measure, all right? It does not. It does not provide a way to measure the motion. It allows to observe the motion, but it doesn't provide a way to measure the motion. So that's a key point there about reference frames. So you have a fixed points. In this case, you have 3 points in space, and you will use them to observe if something is moving or not. If I have, for example, a little guy over here. So if you take those 3 dots as your reference, and assuming these dots are fixed in this problem or in this example, well, you would know that this guy over here is definitely moving and it's definitely hit the ground, okay, if it keeps moving that way. But you only are able to draw that conclusion because you have a reference frame defined over here. All right, now the other question is, why do we need to have these reference frames? And well, the answer is that this kind of frames, and which we call inertial frames, okay, that means again fixed frames or moving with a constant velocity. All right, if we have this inertial frames, Well, they're important because it is an axiom of Newtonian mechanics that such frames exist because the laws of Newton are valid only in inertial reference frames. So that's why it is important to have this concept of reference frames, because we want to observe motion and we want to study motion of systems. And you can call it mechanical engineering, you can call it aerospace engineering, you can call it materials engineering. Many disciplines you would need to define reference frames. All right. Now, if we go back to those diagrams that you find in the internet, right, you will see something like 3 arrows for 3-dimensional space to define a reference frame. That's how you would normally find it. And the reason is because a reference frame and a coordinate system, those are concepts that are very related. And let me tell you why. So if you have your reference frame, all right, let me actually erase this vectors just very quickly. And let me draw up my 3 dots that I need and assume those are fixed with respect to each other. Right now, I just defined a reference frame. But now, okay, this reference frame lets me observe motion. But what if I also want to measure motion? Right? If I want to measure motion, well, I would need a coordinate system. And a coordinate system can be overlaid on a reference frame. And that's what you would normally see as those 3 vectors for 3-dimensional space defined in a way like this. And with these vectors now, I can actually measure motion. And I can do that because, well, if you ever deal with coordinate systems, well, you have something to measure along this direction. You will have something to measure along this direction, and you will have something to measure along that direction, right? And those could be meters, those could be meters per second. It could be something, can be acceleration, it could be magnetic field intensity. Once we have our coordinate system, and let me actually write that here. Now that we have our coordinate system, we can actually measure motion. And something very interesting is that a reference frame, let me draw another reference frame over here. Reference frame can be the home of an infinite number of coordinate systems, right? And if you take this vector right here, this vector right here, this vector right here, we are defining or overlaying a way to measure motion in this reference frame. We normally, for convenience, would have drawn our coordinate system like this, but there's no restriction on making your drawing like this. You could also do that because, again, the 3 dots are just to say, hey, this is something fixed, and the arrows or the vectors are to measure motion along those directions. All right, so actually you could define it like that. You could have do what I did before and just define it like this. So you can have infinite ways to define a coordinate system using this reference frame. Now, of course, again, I mentioned this before in the video, but reference frames in coordinate systems are very connected, and that's why you will normally see that you use both terms like synonyms, but they are actually in definition different. All right, so to summarize, we have a coordinate system that's defined normally like vectors or directions to measure motion, and we will have our reference frames, which are a collection of points, and these are normally fixed for many examples, but this could also be moving at a constant speed. And when you overlay a reference frame and the coordinate system, well, you will see something like, again, what you normally see in books, which looks like this. Let me enlarge this a little bit. You would see something, actually, let me just redraw this real quick. If you have your reference frame and you overlay that coordinate system, you would find this diagram very, very familiar. And if you want to make it a little bit more familiar, you would add X, Y, or Z, or I, J, K, or anything that you might be familiar with. So this is what you will normally see in the definition of a reference frame, which is a set of points, a collection of points that are fixed or moving at constant speed, and a coordinate system, which is used to measure motion.